Congratulations to the video lecture series. I am Adil Mansoori from Civil Engineering Department of LJ Institute of Engineering and Technology. So my dear students, in the previous video, we had already discussed regarding the BOD and the first stage of BOD, right? In this video, we will start with disposal of wastewater, but before that, we will continue with the numerical of BOD. So the data says if the 5-day BOD at 20 degrees centigrade temperature of a wastewater sample is found to be 160 milligram per liter, then find 2-day BOD at 30 degrees centigrade temperature of the sample. We are told that assume KD 20, that is coefficient at 20 degree to be 0.1 per day. Okay, so let's start with the solution. So we are given the 5-day BOD at 20 degree. It means Y5 at 20 degree is equals to 160 milligram per liter. Okay, so BOD is represented as Y. Okay, so if it is 5-day BOD, then we write in subscript as Y5 in the bracket at 20 degree centigrade. Okay, then we need to find out 2-day BOD at 30 degree centigrade. Okay, now we are given constant KD at 20 degree as 0.1 day per day, right? So first we should find out constant at 30 degree centigrade. Now to find out the constant, we have formula that KD at any temperature T equals to KD at temperature 20 degree centigrade into 1.047 raised to T minus 20 degree. That is, T should be the temperature at which we need to find out the constant. Okay, so if we need to find out the constant at 30 degree centigrade, then we can write that KD 30 degree equals to KD at 20 degrees 0.1 into 1.047 raised to 30 degree minus 20 degree. Okay, so KD at 30 degree comes out to be equals to 0.158. Okay, now at 20 degree centigrade and 5 day, we have Y5 equals to 160 milligram per liter. Now from the equation of YT, right, YT equals to L into 1 minus 10 raised to minus KDT. Okay, now YT is given as 160 equals to L, 1 minus 10 raised to minus KD is already at 20 degree, that is 0.1 into 5. Okay, fine. So this comes out to be equals to 160 equals to L into 0.6837. Therefore L is equals to 234 milligram per liter. So this is the organic matter which is present at the start of the BOD reaction. Okay, now again YT equals to L into 1 minus 10 raised to minus KDT. We know the formula, right? Now we have received this L, right? We have already found out the L, that is initial concentration, right? So we can find out BOD concentration at the required day. Okay, so we required at 2 day, right? That is after 2 days. So Y2 will be equals to L. In place of L, I am putting 234, 1 minus 10 raised to minus KD T, right? Where if you are finding at 2 day at 30 degree, then we need to take the constant KD at 30 degree that we have found out, that is equals to 0.158 into 2, right? So this comes out to be equals to 120.96 milligram per liter. Okay, so this is the numerical for finding out the BOD. Okay. Okay, students. So let us now start with the next topic, that is disposal of wastewater. Okay, so there are various methods of disposal. There are two types basically. First one is natural methods, right? And another one is known as artificial methods. So in natural method consists of by dilution, that is by diluting the wastewater, and second one is the land treatment. Talking about the artificial methods, there is a primary treatment and the secondary treatment. So let us now start with the dilution. So dilution is predominant natural method of disposal. Okay, and disposal by dilution is the process where the raw or treated sewage is discharged into water bodies such as rivers, lakes, sea, etc. Okay. Now, the discharge sewage in due course of time is purified by self-purification process of natural waters, and the sewage is mainly purified due to the oxidation of organic matter by bacteria using the dissolved oxygen which is present in the water bodies. Okay. Now, the degree of treatment given to the raw sewage before disposing it into any river will depend not only upon this quality of raw sewage but also on the self purification capacity of the river and the intended use of its water at the downstream side. Okay, and this method can be used only for the towns or cities which are located near the river or sea or have a large lake which can be used as a source of disposal. Okay, so you can see in the picture, right? So let us move ahead. So let's talk about the condition favoring disposal by dilution. Okay, so when the sewage is comparatively fresh, that is, it is discharged within 3 to 4 hours of its collection, then you can go for disposal by dilution. Okay, then when the floating matter and settleable solids have been removed by primary treatment, then you can use dilution method. Then, when the diluting water has a high dissolved oxygen content, so that not only the biochemical oxygen demand is satisfied, but also sufficient dissolved oxygen remains available for the aquatic life. Okay, then where the dilution waters are not used for the purpose of navigation or water supply for at least some reasonable distance on the downstreams from the point of disposal of sewage. Okay, next you can go for dilution where flow current of the diluting waters are favorable and causing no deposition or destruction of the aquatic life. Okay, it means that swift forward currents are helpful as they easily carry away the sewage to the point of unlimited dilution. On the other hand, slow back currents tends to cause sedimentation, resulting in large sludge deposits. Okay. Now you can also use the dilution process where the wastewater does not contain industrial wastewater having toxic substances, and where the outfall sewers of the city or the treatment plant is situated near some natural waters. Okay. So let us now move ahead. So these are the different favoring conditions for disposal by dilution. Okay. Next is standards for dilution. So you can see there are two columns, one stating dilution factor and other standards of purification required. Okay. So dilution factor of 500 or above is required, right? So if dilution factor is above 500, then no treatment is required. Raw sewage can be directly discharged into the volume of dilution water. Okay. If dilution factor is between 300 and 500, then primary treatment such as plain sedimentation should be given, and the effluent should not contain suspended solids more than 150 ppm. Okay, between 150 and 300, if the dilution factor is there, then treatment such as sedimentation, screening, essential chemical precipitation, then the sewage effluent should not also contain suspended solids more than 60 ppm. And if dilution factor is less than 150, then complete thorough treatment should be given to the sewage, and the sewage effluent should not contain suspended solids more than 30 ppm, and its 5-day BOD at 18.3 degree, or we usually take as at 20 degree, should not exceed 20 ppm. Okay. So let's move forward. The next topic is types of receiving waters for dilution. Okay. Now, the following are the types of receiving waters into which wastewater or effluent can be discharged for dilution. Okay. So the first one is perennial rivers or streams, then lakes, then oceans or sea, then it is estuaries, then creeks, right? So let me discuss each of these in detail. So perennial rivers or streams are probably the best type of receiving waters since the water is in continuous motion. Okay, so perennial rivers are the rivers which flow throughout the year. Okay, also in natural streams there is a balance between plant and animal life. Okay, with considerable interaction among the various life forms. However, the discharge flowing during summer and during winter varies in streams. Clear? During summer, there may be minimum flow in the stream, so the dilution factor may be low. And also, higher temperature of water may result in low solubility of oxygen, necessitating proper treatment before dilution. Okay, so this was regarding perennial rivers and streams. Then sometimes, especially when perennial streams are not available, then you go for lakes. Okay, so various characteristics of lakes such as size, shape, volume of fresh water flowing into it, etc. should be critically examined before deciding the self-curing capacity. Okay, then talking about oceans or sea, oceans has abundant water so that dilution factor is unlimited, number one. Okay, however sea water has about 20% less dissolved oxygen than river or stream. The water is turbid due to dissolved impurities and penetration of sun rays is also less. Okay. Now, due to this, proper care has to be taken in dilution by sea. Otherwise, anaerobic conditions would occur, resulting in forming of sludge banks and emission of foul odor. Okay. Talking about creek, then a creek is in the form of an inlet on the sea coast. Okay, which may not have dry weather flow during some part of the year. Due to this, great care should be taken in disposal of effluent into it. Clear? Then talking about estuaries, it is wide lower tidal part of the river. Hence, dilution is affected both by ocean water as well as river water. However, the process of dilution is generally satisfactory in such cases. Okay, so these are the different types of receiving waters for dilution. So let us move ahead. So next topic is self purification. Okay, now when the wastewater or effluent is discharged into natural body of water, the receiving water gets polluted, right? Because we are dumping waste products. Okay, now the conditions do not remain so forever. Okay, because it does not remain that is polluted, because the natural forces of purification or natural action of purification such as dilution, sedimentation, oxidation, reduction, etc. go on acting upon the pollutants and bring back the water into original conditions. Okay, so the actions which are involved in self purification include dilution, dispersion, sunlight which acts through biochemical reactions, chemical forces aided by biological factors called biochemical forces, which include oxidation, that is biooxidation, and reduction. Okay, so this automatic purification of water, polluted water in due course of time is called the self-purification. Okay. Now the organic matter present in the sewage is broken down by bacteria which are present in the streams of water to ammonia, nitrate, sulfate, and carbon dioxide. Now, in this process, dissolved oxygen content of the natural water decreases and deficiency of dissolved oxygen is created. Now, the dissolved oxygen is replenished by diffusion of oxygen from the atmosphere, which is known as reaeration. The stable byproduct of oxidation mentioned above are utilized by the plants and algae to form the foods for protozoa, rotifers, or crustaceans. Okay, they they in turn become food for tiny fishes, which become food for man. So the man discharges his waste back into the stream. Thus, the natural cycle of self-purification continues and the river water regains its original quality. Now, the complete self-purification process is only possible if the concentration of pollutants is less than the assimilative capacity of the river. It becomes polluted and aquatic life gets affected as some minimum dissolved oxygen is required for the survival of fishes. Okay, so let us move ahead. Let's talk about dilution. So when the wastewater is discharged into large volume of water contained in the river or stream, it gets diluted, due to which the concentration of organic matter is reduced and thus the potential nuisance of sewage is also reduced. If Cs and Cf are the concentration of any impurity such as organic content, BOD, suspended solids, dissolved oxygen in the sewage, and river having discharged QS and QR respectively, then the resultant concentration C of the mixture can be given by CS into QS plus CR into QR equals to C into QS plus QR. Okay. Therefore, C equals to CS into QS plus CR into QR upon QS plus QR. So this is the formula for dilution. Okay. So that is the resulting concentration. So next is dispersion. So self-purification of stream largely depends upon currents which will readily disperse the wastewater in these streams, preventing local high concentration of pollutants. Now, high velocity also increases the reaeration, which reduces the time of recovery through length of the stream affected by wastewater is increased. Okay, let's talk about sunlight. So you can see the picture. So sunlight acts as a disinfectant and stimulates the growth of algae. They produce their own food by the process of photosynthesis, right, which produce oxygen during daytime but utilizes oxygen at night time. Hence, whenever there is algal growth, the water may be saturated with dissolved oxygen during daylight hours through anaerobic condition exist in night. Okay, so let us move ahead. Next is oxidation. So the oxidation of organic matter present in the sewage effluent will start as soon as the sewage is discharged into the river. Okay, now the anaerobic bacteria will oxidize the organic matter utilizing the dissolved oxygen of the stream. The deficiency of oxygen so created will be filled up by the atmospheric oxygen, and the process of oxidation will continue till the organic matter has been completely oxidized. This is the most important action responsible for effecting the self-purification of the rivers. Okay. Next is reduction. So reduction occurs due to hydrolysis of organic matter settled at the bottom of either chemically or biologically. Okay. So anaerobic bacteria will help in splitting the complex organic constituents of sewage into liquids and gases, thus paving the way for their ultimate stabilization by oxidation. Okay. So these were the different actions which takes place in self purification. So let us now discuss regarding the factors affecting the self-purification capacity. So there are different factors: temperature, hydrographic factors such as velocity and surface expansion of the rivers or stream, rate of reaeration, amount and type of organic matter, then available initial dissolved oxygen, types of microorganisms present. Okay, so let us discuss each of this. Okay, so the rate of biological activity increases with the increase in temperature and decreases with decrease in temperature. Hence, the rate of oxygen demand also increases with increase in temperature and decreases with decrease in temperature. Okay. The dissolved oxygen content of water, which is very essential for maintaining aquatic life and aerobic condition, is also influenced by the temperature. The solubility of oxygen decreases with the increase in temperature. So, at higher temperature, the rate of biological activity is high and the dissolved oxygen concentration is low, causing rapid depletion of dissolved oxygen. This can result in a development of anaerobic condition and subsequent odor nuisance. Okay. Now, if in a swiftly moving stream, that is with high velocity, the oxygen is replenished quite quickly. Okay, so the water surface at the air liquid interface is being continuously replaced by the turbulence of the stream movement. The oxygen saturated layer is overturned and replaced by an oxygen deficit layer. Okay, in this way the oxygen saturated liquid is rapidly mixed throughout the stream to supply the microorganisms with sufficient oxygen. Okay, now too high velocity is also not preferable because it will create a lot of turbulence which will scur the bottom of the bed, okay, and increase turbidity and retard the algal growth. Now, in a slow moving stream, the surface water is not being turned over and the stream tends to flow in distinct layers. At the air liquid interface, the water is saturated with oxygen, which can mix with the oxygen deficit layers only by slow diffusion. And the failure to replace the oxygen being used in the lower region of the stream allows anaerobic condition to develop. Okay, so next is types of microorganisms present. That is, if algae are present along with the bacteria, reaeration would increase as algae takes in carbon dioxide and gives out oxygen. So oxygen gets added by algae as well as from the atmosphere. Okay, thus increasing the dissolved oxygen concentration and thereby increasing the self purification capacity of the river. Okay, so next is zones of pollution in a river or stream. Okay, so a polluted stream undergoing self purification can be divided into four different zones. First is known as zone of degradation, second is known as zone of active decomposition, third is known as zone of recovery, and fourth one is known as zone of clearer water. Okay, so let us start with the first one, that is the zone of degradation. Okay, so let me show you a picture, right? So you can see that there are four different zones of pollution. First one is initially there will be clear water, then there will be zone of degradation, then there will be zone of active decomposition, then zone of recovery and zone of clearer water. Okay, so what does zone of degradation mean? So this zone is found for certain length, okay, just ahead of the point where sewage is discharged into the river. Okay, so this zone is characterized by water becoming dark and turbid with the formation of sludge deposits at the bottom. Because of this, bacteria will start oxidation of the organic matter and the dissolved oxygen is reduced to about 40% of the saturation value at 30 degrees centigrade. Okay, and it is approximately 7.6 milligram per liter of dissolved oxygen, whereas at 20 degrees centigrade it is 9.17 milligram per liter. So there is an increase in carbon dioxide content and oxygenation occurs, but it is at a slower rate than deoxygenation. Okay, these conditions are unfavorable to the development of aquatic animals, and as such, algae dies out, but certain type of fish may be present feeding on fresh organic matter. Okay, students. So next is zone of active decomposition. So this zone is marked by heavy pollution and it is characterized by water becoming grayish and darker than the previous zone, that is of the zone of degradation. In this zone, dissolved oxygen concentration falls down to zero, right? As a result, anaerobic conditions will set up, resulting in formation of gases like methane, carbon dioxide, hydrogen sulfide. Okay, and lot of sludge is coming to the surface, forming an ugly scum layer at the top. Okay, now as the organic decomposition slackens due to stabilization of organic matter, rate of deoxygenating becomes lesser than the reaeration rate, and dissolved oxygen again rises to the original level. Okay, so initially what happens, decomposition at a higher rate and dissolved oxygen will reduce to zero, but as it will reduce the decomposition rate, so the dissolved oxygen will start on increasing and it will again rise to the original level of 40%. Now in this region, the bacteria or flora will flourish. At the upper end, anaerobic bacteria will replace the aerobic bacteria, while at the lower end, the position will be reversed. Protozoa and fungi first disappear, then reappear. Fish life will be absent. Algae, tubifex will also be absent. Maggots and cycoda, that is sewage fly larvae, will however be present in all but most septic sewage. Okay. Next is zone of recovery. So in this zone of recovery, the river stream tries to recover from degraded condition to its former appearance. The water becomes clearer and so the algae reappears while fungi reduces. BOD decreases and dissolved oxygen content rises above 40% of the saturation value, and protozoa, rotifers and large plants like sponges and bryozoans, etc., will occur. The organic material will be mineralized to form nitrate, phosphate, and carbonates. Okay. Last is the zone of clearer water. So in this zone, the river attains its original condition with dissolved oxygen rising up to the saturation level. That is, okay. Water becomes attractive in appearance. Fish, which requires at least 4 to 5 milligram per liter of dissolved oxygen, and usual aquatic life prevails. Some pathogenic organisms may still, however, survive and remain present, which confirms the fact that once the river water has been polluted, it will not be safe for drinking unless it is properly treated. Okay, so these were the different zones of pollution in a river or stream. So let us now talk about Diossac curve. Okay, so you can see in the screen on the y-axis, that is dissolved oxygen. Okay, it is in percentage, and on the y-axis it is time of flow. Okay, so first let me talk about deoxygenation. Okay, so the curve 1 is the deoxygenation curve, which shows that with the passage of time the dissolved oxygen is reducing. Okay, so deoxygenation curve, what does it mean? So in a polluted stream, the dissolved oxygen content goes on reducing due to decomposition of volatile organic matter. Now the rate of deoxygenation depends upon the amount of organic matter remaining to be oxidized at the given time, as well as the temperature of the reaction. Hence, at a given temperature, the curve showing depletion of dissolved oxygen with time, which is called deoxygenation curve, is also similar to the first stage of BOD. Okay, so here on the screen you can see the curve which is coming downwards, right, which is showing curve 1, deoxidation curve, or curve showing the depletion of DO in the absence of aeration. Okay, now next curve 2, it is reoxygenation curve. Okay, that is DO content supplied. Okay, now oxygen which is consumed by the bacteria in oxidation of organic matter is replenished from the atmosphere, and this process is known as reoxygenation process. Okay, the rate at which the oxygen is supplied by the atmosphere to the polluted water depends on different factors like velocity of the stream and the resulting turbulence created. More the velocity, more will be the oxygenation rate. Now second is the depth of the receiving water. Lesser is the depth, more will be the rate of reoxygenation. Then temperature of water, rate of reoxygenation decreases with increase in temperature. Okay, and then the saturation deficit or the oxygen deficit below the saturation value. Okay, depending upon these factors, the rate of deoxygenation can be expressed mathematically and plotted in the form of curve called reoxygenation curve. Okay, and finally the next curve, which is known as oxygen sac curve or oxygen deficit curve or DO sac curve, is the curve which is on the top portion, that is curve 3, oxygen sac curve. Okay, so in running polluted stream exposed to the atmosphere, the deoxygenation and reoxygenation processes occur simultaneously. If the deoxygenation is more rapid than the reoxygenation, and oxygen deficit occurs, number one. And the amount of the resultant oxygen deficit can be obtained by algebraically adding the deoxygenation and the reoxygenation curves. Okay, the resultant curve so obtained is known as the oxygen sac curve or oxygen deficit curve. Okay, clear? So as you can see that with the passage of time, the rate of dissolved oxygen reduces, which is denoted by curve 1. With the passage of time, reoxygenation occurs from the atmosphere, which is shown by curve 2, and the deficit of the oxygen, right, the deficit of the oxygen will be obtained by algebraically adding those two curves, which is known as DO sac curve, that is the curve number 3. Okay, so next is disposal in lake. Okay, so disposal of wastewater in confined in much more harmful than its disposal in flowing streams and rivers. Water quality management is entirely different from that is in rivers. Now river is flowing water body while lake is stagnant water body. Okay, so in lakes only top surface would become saturated with dissolved oxygen, but the bottom layers would not have enough oxygen. Overturning of the layers would not occur frequently, so the dissolved oxygen content would not be uniform throughout the depth of the lake. Overturning takes place only when there is a change in the season, due to which there will be temperature difference between water in different layers, which causes change in the density of different layers, and overturning occurs. Okay, so this is the disposal in lakes. Okay, students. So let us now move towards the next topic, that is the eutrophication. So you might have seen in different water bodies that the top layer of the water body is covered with algae or any other aquatic plants. Okay, so phosphorus acts as the nutrients for algal growth. Okay, an increase in phosphorus content would increase the algal growth. Excessive amount of the phosphorus content would increase the algal growth. So excessive algal growth will create lot of problems like taste, odor, problems in oxygen diffusion in lower layer. Ultimately, the entire lake gets covered with the algae and it may become useless for other organisms. So this process is known as eutrophication. Okay. So let us now move towards the next topic, that is disposal of sewage on land. Okay. So in this method, the sewage effluent treated or either it's raw is disposed of on the land by applying on it, and the most common forms of land application are irrigation, that is known as sewage farming, or rapid infiltration. Okay, when raw or partly treated sewage is applied on land, a part of it evaporates and remaining portion percolates in the soil. If proper voids are maintained in the soil, the organic sewage solids are oxidized by the bacteria present in the soil under aerobic condition. However, if the soil is made of heavy, sticky, and fine-grained materials, the void space will soon get clogged, resulting in non-aeration of these voids, which would lead to anaerobic condition and subsequent evolution of foul gases. Application of too strong or too hard sewage will also result in quick formation of anaerobic condition, and the load of sewage can be reduced by dilution or pre-treatment. So you can see the picture of sewage disposal on land. Okay, and these are different standards of wastewater effluents to be discharged on land for irrigation. Okay, students, so let us now move towards the next topic, that is sewage farming. Okay, so in irrigation, sewage is used for irrigation of crops. Okay, in this method, this not only disposing of sewage occurs, but also it helps in yielding the crops. Okay, it increases the yield capacity of the crops because sewage contains lots of nutrients. Okay, however, the sewage effluent may be made safe before using it for the irrigation. Okay, so you can see the pictures of sewage farming. So next topic is sewage sickness and its preventive measures. So when sewage is applied for continuously on a piece of land, the soil pores or voids may get filled up or clogged up with sewage matter retained in them. The time taken for such clogging will depend upon the type of soil and the load present in the sewage. But once these voids get clogged, free circulation of air will be prevented and anaerobic condition will develop within the pores. This results in decomposition of the organic matter, right, under an anaerobic condition, and this results in evolution of foul gases like hydrogen sulfide and carbon dioxide and methane. This phenomenon of soil getting clogged is known as sewage sickness. Okay, talking about its preventive measures, then primary treatment of sewage should be done. So the sewage should be disposed of only after primary treatment, such as screening, grit removal, and sedimentation. This will help in removing sedimentary solids and reducing BOD load by 30% or so, and soil will not get clogged frequently. Then another preventive measure is a choice of land. The piece of land used for sewage disposal should normally be sandy or loamy. Okay, clay soils or clay lands should be avoided. Under drainage of soil is one of another preventive measures, that is the land on which sewage is to be applied or disposed can be drained, and if system of under drains is laid below to collect the effluents, then this will minimize possibility of sewage sickness. Then another one is giving rest to land. So the land being used for disposal should be given rest periodically by keeping some extra land as a reserve and standby for diverting the sewage during the rest period. Moreover, during the rest period, the land should be thoroughly plowed so that it gets broken up and aerated. And last method is rotation of crops. So sewage sickness can be reduced by planting different crops, and this will help in utilizing the fertilizing element of sewage and help in aeration of soil. Okay. So with this, my dear students, we complete the portion of sewage disposal as well. Okay, so we will be starting with the new topics in the next video.